Yeah. All right. Thanks, Andy. Welcome everyone to the symposium on spontaneous mathematical focusing tendencies, and of course, then the development of early math skills. We have 3 talks today. First, Nore Wijns from KU Leuven is going to talk about a relatively new focusing tendencies, which I don't know if people actually call SFOP, but at least that could be what it could be referred to, but it's spontaneous focusing on patterning. And then Alex Silver is going to present some work on predicting SFON, and then Minna Hannula-Sormunen is going to talk about some intervention studies and also sort of early childhood settings for promoting early numeracy and SFON as well in there. You'll note that we only have 3 presentations today. And since we didn't have a discussant planned either, we'll have a little bit more time, hopefully, for some discussion. And I think we'll try and plan a little bit in between the talks, and then hopefully we can have some interesting discussion at the end as well. But yeah, so I guess we can go ahead and start with Nore.
Okay, thank you, Jake, for introducing me and for organizing the symposium. And hello, everyone. Thank you all for joining our symposium. My name is Nore Wijns, and I work at the University of Leuven. And as Jake already mentioned, I'm going to talk to you today about young children spontaneous focusing on patterns by means of a longitudinal study that I conducted together with my supervising team that consists of Leuven, Bert Smith, and Wijns. And this whole symposium is about spontaneous mathematical focusing tendencies. And the idea behind this research is that children differ to the extent to which they attend spontaneously to mathematical elements in their environment. So spontaneously, that means without being told so. And the main reason why we are interested in this, why we are doing research into this, this idea, let's say, is of course because there's this hypothesis, and it's already proven as well, that this spontaneous association is related to children's mathematical abilities. And there are different mathematical elements to which children could spontaneously attend. And the most important, or the first concept that was already researched is SFON, or children spontaneous focusing on numerosities, and this research started with the work of Minna, who will talk to you later on. But in the meantime, other spontaneous focusing tendencies have already been addressed as well, such as children spontaneous focusing on arithmetic number symbols, or children spontaneous focusing on quantitative relations. Like Jake already mentioned, I'm going to talk to you today about a relatively new spontaneous focusing tendency. We called it SFOP, or children spontaneous focusing on patterns, like the repeating pattern that you can see on the slide here. We created a new task to measure this SFOP concept already a couple of years ago, and it's actually very simple. We simulated a free play situation in which we provided preschoolers with a set of 15 blocks in 3 different colors, and we simply asked them to create a tower using all of the blocks provided. And of course, we did not tell anything about the rest of the activities that were taking place, so we did not. This was the very first task that we administered, and we did not say anything about patterns, numbers, or mathematics beforehand. After we administered this task, we took a picture of each of the towers that was created, and we then tried to categorize these constructions of the children. And the first category was, of course, pattern category. And this category included all towers that represented a repeating pattern. And we defined a repeating pattern as if there were at least 2 full units of a pattern and the start of a third one. And the unit is the smallest part of a pattern, a repeating pattern that repeats. So in the first tower that you can see, it will be red, yellow, blue, red, yellow, blue, red. In the second tower, it will be yellow, red, yellow, red, yellow. That will be sufficient in order to have a pattern, a tower categorized as pattern. And our first idea was, okay, this is simple. We have a pattern group and all the other tower constructions are random. But of course, preschoolers never disappoint. And we had something that we did not expected beforehand, but we're still confronted with, namely that a lot of children, or quite some children, sorted all the blocks on color. And yeah, we had some struggling with this because it did not fit with our idea as a repeating pattern or a pattern. But we also felt like this was not really random behavior. Clearly, these children had some spontaneous attention for the color in those blocks, and they wanted to apply some sort of structure to it. That could also be mathematically meaningful. Sorting elements might be necessary if you want to count, for example, the blue versus the yellow versus the red blocks. So therefore, we decided to start working with these three different categories. And for those things, we presented this task to a group of 4-year-olds, and we already published one paper on this data. You can find it in the British Journal of Educational Psychology for those interested. And in that study, we compared these three groups of children on their patterning ability, numerical ability, and spatial skills. But of course, I promised you today to talk about a longitudinal study, because this was only the beginning. We then followed up this group of children for 2 more years. So today I'm going to talk to you about a longitudinal study in which we followed a group of more than 300 children for 3 years. And at the start of this study, children were about 4 years and 10 months old. In Flanders, children are at that time point in the 2nd year of kindergarten or at the end of their 2nd year of kindergarten. We really assessed their SFON, repeating patterning ability, and numerical ability at 1 year later at age 5, and again 1 year later at age 6, when they were at the end of the 1st year of primary school. We also included a measure of spatial visualization, which was measured at the start of 3rd year of kindergarten. I'm now going to take you through the different tasks that we administered. So as I already mentioned, this was our tower task. But for this particular longitudinal study, we first decided, for this MCLS symposium, we decided to combine the first 2 groups, so the pattern group and the sorting group, as a structure group, because both groups apply a structure to the elements in the tower. And our first study also showed that both groups had relatively strong patterning and spatial skills as compared to the random group. When looking at our patterning ability measure, we found, no, we did not find anything. This is our task. So we had 3 activities that were included for 6 repeating pattern items, an extending task in which children had to indicate which of the 4 options was a correct extension, a translating task in which children had to copy the pattern but using different materials, and then finally an identification task in which children had to memorize the pattern and to copy it from memory. And the idea here is that children have to identify the underlying structures, in this case part that repeats, in order to be able to reconstruct it from memory. Then for numerical ability, we used a different set of tasks at 3 different time points in order to have sufficient variability across time points, but the same constructs were included. Those were counting, number comparison, number order, number identification, and basic arithmetic. And we created a standardized value for each performance on each task, and then we At each time point, we calculated the average, and this was the value for numerical ability for each child. And spatial visualization was the block design task of the WIPC, which is probably familiar for most of you. And this brings me to the main research question for this study. And that is, of course, that we were interested in evaluating the association between children's spontaneous focusing tendency and their mathematical ability. And in a first step, we did so by looking at children's spontaneous focusing tendency at the start, so at age 4, when they were in second year of preschool. And we then looked whether this was related to mathematical performances at age 4, 5, and 6. So what did we find? First, when we look at the two groups, so the children who created a structure versus the children who made a random arrangement at age 4, we see that about half of the children created a structure, whereas the other half made a random arrangement, so it's about 50-50. The mean age of both groups is similar, but we did find significant differences in spatial visualization in favor of the children who created a structure at age 4. We then evaluated whether there were differences in patterning ability, both cross-sectionally and longitudinally, and we did find significant differences each time in favor of the structure group at the 3 different time points. So to be clear, children who created structures, so either created a pattern or sorted the blocks on cover at age 4, had significantly better patterning ability 2 years later at the end of first grade than children who made a random arrangement. We also compared these two groups' numerical ability, and there you can again see that the structure group always outperforms the random group, but this is only significant cross-sectionally at age 4. But of course, as I already mentioned, there were differences in spatial visualization between these two groups, and we all know that both patterning and numerical ability is associated with this spatial visualization, and therefore we also evaluated whether these differences maintained after taking into account spatial visualization. And for patterning, this was the case at age 4 and at age 5. That is, age 6, these differences disappear, and also the differences in numerical ability disappear when taking into account spatial visualization. So it seems like spatial visualization counts for this difference in numerical ability between the two groups. So far, so good. But we, of course, had a measure of SFON or tower task. We administered it at 3 different time points. And therefore, we were thinking whether we would be able to find a combined measure or value for performance on this, or behavior on this SFON task at the 3 different time points. We've been thinking a lot about it, and we would still appreciate any suggestions from you afterwards to help us get a grip of this data. But as a first step, we now created a new measure for each time point. We give a value of 0 if children created a random arrangement, and a value of 1 if they either created a pattern or sorted the blocks. So you apply the structure to the tower, and then we created a sum. So this new measure represents, or this new value represents how many times a child applied a structure across these 3 time points. And this is then a value between 0 and 3. 0 meaning the child never created a structure, 3 meaning the child always created a structure, so either sorting or creating a pattern. And then again, we evaluated whether there were differences between these 4 groups on the ability measures. So if we take a look at some descriptives first, then we see, so the number on the top of the table, of course, represent the number of times the group of children created a structure. And we see that about 1/3 either created a structure at 3 time points and another third at 2 out of 3 time points. And only a minority of children, about 10%, never applied a structure in our task. The mean age of children, again, at start of our study was similar, but we again found differences in spatial visualization. Children who created a pattern or sorted the blocks at all 3 time points had significantly better spatial visualization skills than children in the other 3 groups. Then, with regard to repeating patterning ability, the pattern, I would say, is clear. So again, children who created a structure at the 3 time points have significantly better patterning ability than the other 3 groups, and the children who never created a structure have significantly worse patterning ability than the other 3 groups. For numerical ability, it was less straightforward, but still we see a similar pattern at age 4, so 2nd year of kindergarten, and age 6, 1st grade. We see that children who created a structure at the 3 time points had significantly better numerical ability than the other 3 groups, whereas at age 5, 3rd year of kindergarten, children who never created a pattern had significantly, or sorted the blocks, had significantly lower numerical ability than the 3 other groups. So overall, we can see that the group who always applied a structure has better mathematical abilities as compared to the group who never created a structure. But then, of course, what happens if we take into account these spatial visualization skills? For patterning, there are still significant differences between the groups, but there are some shifts with regard to which which group differences remain. So it's first time point, 2nd year of kindergarten. Again, the group who always created a structure was significantly better, whereas 3rd year of kindergarten and 1st grade, the group that never created a structure was significantly worse. And then for numerical ability, again, all differences disappeared when taking into account spatial visualization, or better, they were no longer significant. So what can we conclude from this study? I think it is fair to say that spontaneously applying a structure to elements is related to spatial visualization skills, to patterning skills, even up to 2 years later, and even to numerical ability. But of course, this was accounted for by the differences in spatial visualization. And with regard to our tower task, it is a very simple and short task to apply. And we were a little bit depressed as well about how it was still associated with abilities 1 and 2 years later. But of course, we must remain cautious. This was only a first study that we conducted, and the validity and reliability of this measure does require further research by replicating or including more items. But of course, this is always challenging when measuring spontaneous tendency. We don't want to include too many items because this might impact the spontaneity of the results. But we were also thinking that maybe we could relate performance on this task with observational measures of behavior in the classroom or at home. And then, of course, an important aspect or for this presentation, we were focusing on this structure group versus this random group. But of course, in this structure group, there is the pattern group and those children who sorted the patterns. And it's important to figure out differences or similarities between the groups. So this was it for me. Thank you all for joining us today, and I'd be happy to answer any questions if there are.
Wonderful, thank you, Nore. I think we have time for maybe one short question while Alex is setting up, walking to the front and all of that.
I quickly was just wondering, so about half the students were classified in structure and half in random. In the structure group, do you remember about how many were doing patterns versus the sorting?
I think more children were creating a pattern as opposed to sorting. I think in the whole group it was about 1/3 of the children who created a pattern, and I think I have it even here on one of my additional slides. Yeah, about 1/3 of children at the first time point created a pattern. What we did see was that across time points, there was less random behavior, and from within preschool, so from first to second time point, more children started to create patterns. But then when they went to first grade, the sorting went up.
Interesting.
More. And that made us think like, okay, we did expect like there to be some sort of development from maybe random towards sorting towards patterning. But then we figured, okay, maybe in first grade, they are really learning to sort elements, and this might influence our results. So we're not really sure what to do with the developmental aspect.
Yeah, that's interesting. Thank you.
Yeah, thank you.
Okay, great. Thanks, Nore. And thanks for the question, Caroline. Yeah, so Alex, I think, go ahead and take it away.
Okay, great. Hi, everybody. Oh, sorry, there's a weird glare going on. I'm Alex Silver. I'm a graduate student at the University of Pittsburgh. Today, I will be presenting some work led by our postdoc, Leanne Elliott, who has been out on maternity leave. So I offered to present some of her awesome new findings, looking at math skills, predicting children's spontaneous focusing on number through behavior, but not through talk. And so, as Nore kind of mentioned, in everyday life, we face a tremendous amount of perceptual information. So even when doing something as simple as baking, we can pay attention to the number of spoons or eggs, the size of the bowls, the shape or the color of the ingredients. There are just a whole lot of different things that you can attend to. And the tendency to focus specifically on numerical information, or SFON, is typically measured by children's tendency to selectively attend to and utilize numerical information without being prompted. And we typically measure this by seeing how much children notice and pick up on numerical information without being explicitly instructed to. Theoretically, SFON might serve as a link between really foundational number skills like counting and subitizing and later math achievement, where children who are more attentive to numerical information in the environment have more opportunity to learn from this information. But past studies have used several different measures of SFON, which might tap into theoretically distinct aspects of children's attention to number. So in this study, we examine how two distinct ways of quantifying SFON drawn from a common measure might relate to one another and to underlying child characteristics, including children's math skills. And so again, although there are many factors that might support the development of a child's tendency to focus on numerical information, one major concern in the literature is the extent to which past studies have used a wide variety of measures to quantify children's SFON tendency. And specifically, few studies have compared multiple measures of SFON to really formally test the validity of these tasks and whether they capture similar aspects of children's underlying focus on number. The limited work that has compared SFON tasks suggests that there might be divergence across measures, so it's also difficult to determine the extent to which findings from studies using one measure might generalize to work using another measure. And many SFON tasks are modeled after the initial work of Hannula-Sormunen, which instruct the child to imitate an experimenter without specifically mentioning kind of what part of the action to focus on, or giving any other explicit details. In these tasks, children are considered to focus on number if they either kind of recreate the number of actions that the experimenter did, or if they reference the numerical nature of the task, like by asking questions or describing quantities. And traditionally, performance on these types of imitation tasks is collapsed across verbal and behavioral responses, but it's kind of unclear to what extent these reflect similar cognitive processes. And then in comparison to these imitation tasks, a couple of other alternative measures of SFON have been used in recent research. So on the one hand, Batchelor and colleagues measured SFON through picture description tasks, where children are shown cartoon pictures and asked to describe them to an experimenter in addition to doing a traditional imitation task. In these picture tasks, children's SFON tendency is measured by whether children include numerical information in their description of the picture, kind of regardless of whether this numerical information is correct. And then on the other hand, Chan and Mazzocco have recently used an alternative measure of SFON that measures how children attend to number when this numerical information is directly in contrast with other relevant features. So in this task, children are asked to select which of 4 images best matches a target, with each response option sharing one dimension, so being the same number, the same color, the same shape as the target image. And so for a child to be coded as focusing on number here, they would have to select the response that has the same number of shapes as the target, rather than other response options. So here, children have to not just attend to the numerical information, but identify it as kind of the most relevant matching dimension. And across these different tasks, there are several notable differences, as you probably picked up as I was describing them, including how performance is scored, whether math skills are needed to be coded as focusing on number, and also the level of ecological validity. For this study, though, we're really interested in exploring one major difference, which is the response format. So depending on the nature of the SFON task that's utilized, some studies require a verbal response, others can be completed with just a behavioral response. And in some tasks, performance can be quantified based on both verbal and behavioral responses. But there's really limited research exploring what differences in these responses might actually mean. One recent study explored this distinction in SFON tasks by having children complete both an action-based SFON task and a verbal SFON task. They found that performance on the verbal task was unrelated to performance on the action-based measure. And additionally, only performance on this verbal SFON task correlated with the frequency of using number words during a book reading task, which suggests that there's some divergence here between these action and verbal-based measures of SFON. And then in addition to understanding how these various measures of SFON might be related, there's also been a recent push to understand how SFON actually develops and what the underlying cognitive processes are that are associated with its development. Although most studies have examined the ways that SFON might lead to the development of math skills, these associations appear to be bidirectional in nature, as early math skills also tend to predict children's later tendency to focus on number. But in addition to math performance, we really know very little about the factors that might predict why some children attend to numerical information in the environment more than others. And again, although past work demonstrates that SFON is distinctly mathematical, it's likely that broader domain general factors also contribute to individual variability. So for example, executive functioning, or the set of skills including inhibitory control, attention, working memory, and cognitive flexibility, has been found to be positively related to children's SFON, but more work is really needed to explore whether these remain linked even when we control for math skills, given the very large literature finding links between EF and math. And similarly, limited research has addressed the ways that children's language skills might relate to the development of SFON. It's clear from many SFON tasks, language skills are really important for demonstrating your attention to number, but it remains less clear whether potential associations between SFON and language development are attributable to these task demands, such as understanding the directions or providing a verbal response, as some of these tasks require, or whether verbal skills actually support the development of the underlying construct of SFON, such that better language skills help children understand and attend to number in the day-to-day lives. So here we were interested to determine which of these predictors might be related to children's SFON and whether they would similarly predict SFON through action and SFON measured through talk. So in the present study, we explored this possibility within the context of a single type of SFON task. So here we addressed 3 main research questions. First, we asked, how do children's SFON scores differ depending on the modality of assessment when completing a SFON imitation task? So we particularly aim to identify whether children differ in their use of SFON through action and SFON through talk in these tasks, where both modalities can be used to demonstrate a tendency to attend to number. And second, we asked, does SFON measured through action relate to SFON through talk on the same imitation task? So in other words, are these two modalities of demonstrating SFON co-occurring in tasks such that children are both verbally and behaviorally attending to number? And then finally, we asked what underlying factors support SFON in each modality. So we examined the extent to which children's math ability, their inhibitory control, and their vocabulary might uniquely and differentially predict SFON performance measured via action and through talk. So to test this, we had 107 preschool-aged children participate in this longitudinal study. Children were about 4 years old, and they were primarily white, non-Hispanic Latino. So this study brought children into the lab for 3 visits over the course of about 4 months. For the purpose of today's talk, I'm going to just describe the timeline for the measures of interest, and I'll go into details about each of these measures in just a minute. Briefly, at the first visit, children's math performance, inhibitory control, and vocabulary was assessed. And then at the second and third visits, we assessed children's spontaneous focusing on number using different imitation tasks. Okay, so how did we actually do this? Looking first at these predictors of SFON really quickly, assessed at that first lab visit, I'm going to walk through kind of a brief overview, but I'm happy to answer questions about the details. We assessed children's math achievement using the test of early mathematics ability, or the TEMA, which hopefully most of you are familiar with. We used the total number of correct questions that children answered as the measure of their math performance. Children's inhibitory control here was assessed using a modified day-night-Stroop task. So in this assessment, children are shown images and instructed to say day when shown one image and say night when shown another image. In the incongruent task, children have to say night when shown a sun and say day when shown a moon. So this requires them to form this new association between the image and the words, as well as inhibit their prepotent association response. And then we also gave children a control version of this task, where they had to form a new association between the words day and night and simple pattern images to account for any individual differences in children's ability to kind of follow these directions and apply the relevant rule information. And then finally, children's vocabulary was assessed using the Developmental Vocabulary Assessment for Parents, or DVAP, which is a parent report measure of children's language development. So finally, and kind of critically, to assess children's spontaneous focusing on number tendency, we used 3 tasks based off of Hannula-Sormunen's original work. So in the first task, administered at both the second and third visits, an experimenter stamped a quantity of spikes onto a picture of a dinosaur, flipped it over, and then asked the child to do the same to an identical dinosaur picture, saying, "Can you make yours just like mine?" In the second task, administered at that second visit, an experimenter fed quantities of marbles to a toy puppet and asked the child to do it just like me. And then in the third task, administered at the third visit, an experimenter mailed sets of letters into this toy mailbox and asked the child to do it just like me. Critically, for all of these tasks, the experimenter never told the child how to copy them and never explicitly mentioned number. So for these tasks, we coded children's responses for verbal and nonverbal instances of focusing on number. So children were coded as focusing on number verbally if they mentioned number or quantity. So for instance, saying, "I don't remember what you did, but I want to put 5 stamps," saying, "I'm going to feed him 3, or asking, "How many did you do?" Children were coded as focusing on number through action in a given trial if they replicated the number used by the experimenter. So by putting exactly the same number of spikes on the dinosaur, feeding the puppet the exact same number of marbles, or mailing the exact same number of letters. And we created composite variables, one for talk and one for action, calculated as the sum of their talk and action scores for each of these SFON tasks. So turning to our results, we found that overall, SFON through action was significantly more frequent than SFON talk. And we found that SFON talk and action measures were actually not significantly related to one another at the bivariate level. However, given the structure of these tasks that we used, children weren't actually required to talk. So we examined their general talk during these tasks as well. And in fact, children spoke about the task for fewer of 2/3 of the trials on average, which might help explain this kind of mean difference between SFON talk and action measures. When we controlled for the number of trials on which the child spoke about the task at all, we found a significant positive association between SFON measured by talk and by action. So given this kind of moderate association, we were interested to explore whether any of our predictors would relate to SFON action or SFON talk, and if so, whether these two SFON composites would be predicted by similar or different variables. So for both SFON composites, a series of regression models was estimated to explore the factors that predict variability in children's tendency to spontaneously focus on number. So for each SFON composite, we first regressed it on children's prior math ability, their inhibitory control, assessed as performance on the incongruent version of the day-night Stroop task, and controlling for performance on the control version of that task, children's vocabulary, their age at the first visit, and their gender. And then the overall talk measure and the alternative measure of SFON were added to this regression model to examine whether these prior factors uniquely predicted each measure of SFON above and beyond the effects of the other measure and children's frequency of talking during the task. So first, looking at SFON through action, the preliminary model with child predictors from the initial lab visit was significant overall, explaining roughly 30% of the variance in SFON action scores. And we found that children with higher math skills at the first lab visit tended to have significantly higher SFON action scores. Inhibitory control, measured by performance on that incongruent version of the day-night Stroop task, was unrelated to children's SFON through action, as was children's vocabulary. But we found that performance on the control version of that day-night Stroop task did significantly predict later SFON action scores. And we found that these results held even when controlling for SFON through talk and children's overall talk during the SFON task. In contrast, though, SFON talk was not significantly related to any of the child predictors from that first lab visit. But given that a lot of children didn't talk about the task, we added the measure of overall talk during the SFON tasks to this model to see if this might change anything. So this resulted in a significant model, but when also controlling for SFON through action, we saw that there were still no significant predictors of SFON talk. So in summary, we find that children are more likely to replicate an experimenter's action in a way that's numerically relevant than to indicate their attention to numerical information through speech. Although preliminary analyses suggested that these two measures of SFON were unrelated, additional probing revealed that this association was masked by the low level of on-task talk during the tasks more generally. And despite the small to moderate correlation between children's SFON as measured through talk and action, these two constructs were differentially related to the set of underlying predictors of SFON that we measured in this study, suggesting that these two methods of demonstrating attention to number might reflect different cognitive processes. Our findings suggest that SFON might not reflect a unitary construct, as children demonstrate their attention to numerical information in distinct ways that might be related to different underlying cognitive skills. And this work highlights several avenues for future directions, including exploring the various aspects of SFON that are addressed by past measures, looking at additional predictors to understand what it is that SFON talk in this task might reflect, and assessing the unique ways that SFON through action and talk develop over time and might relate to different constructs of math achievement. So in closing, thank you all for being here today. Thank you to Jake for inviting us to be part of this symposium. Thank you especially to my co-authors on this paper, especially Leanne Elliott, who spearheaded this project and whose work I got to present today. Thank you to baby Henry for keeping his mom busy so I get to present for her, and to the members of the Kids Thinking Lab, our funding sources, and importantly, all of the families who participated in this study and continue to help us with our research. So I'm happy to take any questions either now or in the chat, but if we don't get a chance to address them all, please also feel free to email me. Thank you.
Fantastic. Thank you, Alex. Really interesting presentation. Do we have any quick transition questions now? I have a question, but it's not a quick transition question. Yeah. But perhaps we have time for that at the end for a little discussion if people need to leave, but then we can still discuss a little more, since despite only having 3 presentations today, we're still a little behind. So
I tried to talk quickly, sorry.
No, you did great. Yeah. So perhaps, Minna, we can yeah, go ahead and you can go ahead and start.
Just a second, I'm losing myself in these screens now.
Perhaps I'll ask the question while you don't have to answer it, but I can ask it now. But the thing I'm really interested in is you mentioned that there's these different task types that have been discussed or been used.
Mun esitys
So-
alkaa ihan nyt, että
Uh,
there's noise downstairs. Sorry.
What do you think were the effects of using an imitation task and then describing the verbal kind of responses when there's sort of the nonverbal responses are maybe the main mode for maybe there's not enough time to answer that question, but yeah.
I'll think on that and come up. Yeah, no, we definitely have been thinking about that. And I think that there's a lot of future work kind of in this area to really tease this apart, but we can talk about that at the end. And Leanne will be excited.
I was gonna say, yeah, I'm happy to talk
Yeah,
about you.
okay. But Minna's found her presentation now, so.
Hey, can
Successfully.
you see the kind of presentation mode now?
No, we see the main window.
I don't know why it disappears now to the kind of not to the moon, but close to. Is it better now?
Yes, you got it now.
Yeah. Okay, I'm a winner. All right. So thanks for coming and thanks for being there. And my plan is to present briefly about our recent intervention studies and let you know some kind of nice developments in Finland. But let's see. I have really hard time now here. This study is about the interventions. It's been published already in our special issue in mathematical thinking and learning. If I get my numbers wrong, please go and check them from this paper. That's one thing. I would like to ask you to be comfortable now and put your SFON slippers on. As you can see, there are 3 flowers on each one of the 2 slippers, and they make you feel nice. So be my guest and wear the slippers now. Just briefly, the idea behind the whole SFON concept is that and development, how to promote mathematical skills in the early ages, that math is really all around us, but not maybe necessarily all around all of us, but all around some of us. So some children seem to be focusing on numbers, and some educators seem to be focusing on numbers around them. And we have been interested in finding the ways to make more children to focus on number and more educators to start focusing on number. And one thing important here is that I can say it even this strongly. I don't believe that we should be training young children's early mathematical skills in isolated exercises when we drill some simple arbitrary tasks. But I think instead we should be providing young children mathematical exercise that is meaningful and really tightly linked to everyday actions and everyday behavior, so that would help them to transfer their skills, to use their skills in their own lives, because that would promote huge amount of practice in comparison to only those adult guided special math activities or math games or something like that. So the most important learning environments in my mind and are the everyday situations. Those are the most fruitful for the young ones. Thank you, Alex, for doing some work for me and my presentation. I'm going to just to say something and two things. Like you presented nicely the SFON definition, but then the SFON tendency, what we have been talking since day one with Erno. The SFON tendency, we think that across different situations and different tasks and contexts, there is a SFON tendency that is related to how much spontaneous practice children get in using their early number skills. And as you heard already, there's new nice family members for SFON, and SFOP is such a nice title for that. I like it. SFONO is we are working on that. That's spontaneous focusing on numerical order. And then this is from our recent book chapter, where we have been looking at or kind of conceptualizing like what are the parts related to SFON, like spontaneous mathematical focusing tendencies, what's the role of requisite skills, and what are the roles of contextual factors. It's such a pity that Michelle couldn't be here, because their study was exactly about these contextual factors. But each one of these kind of make differences and make individual differences in SFON and contribute to the easiness of how easy it is to be able to focus on number, and how for which child some kind of focusing is even possible in a certain moment. Here's our age-old study, our first SFON intervention study that was forming the basis for our these interventions that I'm presenting now. I just picked up one nice kind of result from there. We have an experimental, we had an experimental group there, and just the business as usual control group in that study. But it was kind of interesting, and even I kind of today when I looked at this, I noticed that, well, there was this difference that the children who were in our SFON experimental condition in a go and pick up as many socks to a caterpillar as the caterpillar needs, this kind of my old caterpillar task, like how many times they tried to count when they were picking up the socks or looking at how many legs the caterpillars had. So the number of counting attempts kind of raised like very nicely as a result of this experiment. So that's kind of a nice idea about like what kind of self-initiated practice this tendency could lead to. So now there's two studies, and this is going to be like a comforting talk also, because it wasn't a perfect success, the study one, but we got better, and the study two has much nicer results for us. We wanted to develop very naturalistic intervention program that could be actually used in the daycare centers in Finland. And in the study one, we had a little bit younger age group, but a very tight age group. And we wanted to develop their SFON and recognition of small numbers, small exact numbers. And we also used lots of fingers to support these skills. And in both of these interventions, we trained early educators in learning about content knowledge and also how to scaffold children's mathematical or these SFON and cardinality skills. In study two, we had 3 to 5 year old children. This is a typical child group in Finnish daycare. And the same skills except for also counting skills. And then we learned some tricks how to better enhance early educators' mathematical skills. In early educators training, we wanted to kind of make them start seeing small numbers of items around them. And we wanted to we had to educate them about, or train them or teach them about how these skills develop. And then we had lectures, designed materials and activities that we designed. And then, because in study one, I think we didn't succeed very well, we developed this kind of video-based training that was much more individualized to the educators in daycare. And Aino Mattinen, who was really doing this training, like visited the daycare centers and these groups regularly. And the examples of activities in both studies, we had SFON attractors, and they were designed and also natural kinds of. We had guided number, related play, and everyday situations. And here's a SFON attractor, so SFON bait. So you can trick your kids at home or even other adults nicely this way. Like you can put similar items to a kind of blank background, and this is something that you can actually make them focus on numbers more. This is actually a more sophisticated SFON attractor because it has two sets there. You can focus on 2 and 3, that becomes 5. So that goes to a much older kids actually. Then if you start looking around, actually you could do that now wherever you are. Like, can you find a SFON attractor, a natural one, like something that could be like that in your setting, hopefully. But when you start looking at, kids are actually doing this and they can find quite nice SFON attractors themselves. And you can also kind of set them up. But these were on the yard. So then we also had guided number, pretended play. So we try to find those kinds of natural situations where small numbers and number recognition would be used. So shopping without any money, of course. But we had this kind of vegetable market that you can see. This boy is putting some cucumbers as requested there. And then all sorts of everyday situations where small numbers of items can somehow pop out. Like when you open a cupboard and then you can see like, oh, there are 2 towels. Wow. And so these kinds of incidents were used. And that's actually a very important thing. And this tries to help the kids to learn to transfer their skills and use them in their everyday surroundings to be able to practice as much as needed. Our research questions were like, does this intervention have an effect on SFON and cardinality related skills? And we were also developing actually the activities that we could be handing to the educators in daycare. We had here a really active control group that had the very similar structure of activities, but it was targeted to listening comprehension skills. The design was such that we had this about 5-week intensive period, and then after that we had this rehearsal phase, like about once a month there was this kind of rehearsal days when they were practicing again these activities and using these activities again. It was not only for the children but also for the educators, because we wanted them to kind of take it, own it, and start using it permanently, not only during this intensive period. Participants we had, I would be ready to say, quite nice numbers of participants. And our measures, we used imitation tasks. Thanks, Alex, again for showing how they were. But then we had the imitation task with a bird, and then a truck, and then a selection task, which is slightly different. And there's some kind of creature that has different numbers of legs, and then there are boxes of socks, and then the child needs to pick up the right box for this creature, this animal or whatever. And then cardinality related skills give me X, and then number word sequence were the measures that we used. In the study one, I'm going to these results quite quickly, so please look at the paper better. But in study one, here's the SFON result, and the groups didn't really differ. And in the cardinality skills, there was a difference to the delayed post-test. That was like 6 months after, but not really before. And then in study two, we had a little raise in the rate. Is that raise? Well, in the SFON tendency, but then it stabilized, like the other group reached it there. But then again, in the cardinality related skills, the groups were differing quite nicely. And then number sequence production was actually similar to cardinality skills in the study too. And then actually what we wanted, because we wanted to develop methods for promoting those children's mathematical skills who are the weakest in the group. So we were interested in looking at what happens in the lower group. We split it exactly half, and then we looked at the lower and the higher group. And the consistent result across the study one and study two was that we were able to promote especially the low group. This was like a very happy news for us, because since the 2005 Hannula-Lehtinen intervention study, there the result was that we were able to promote the ones who already had some SFON tendency in the beginning, so kind of the better ones in that group. And since then we were kind of worried if this is if we can promote SFON in the weaker, not so strong SFON kids. But it turned out that yes, with these new activities and with a better understanding of what SFON is, we could actually do it, especially on the lower skills. So overall, what the results were, so we were able to promote especially cardinality related skills from pre to post test, and then importantly the ANCOVA results showed that when we combine the study groups, that we have really an experimental effect there. And group differences remained significant in the cardinality related skills all the way until the delayed post test. So the conclusions, we are quite preliminary happy about the results of the intervention. So we learned a lot about how to do that in practice, and we designed new activities that seem to be working. We don't know which activity actually leads or improves the skills, so this is a complete package, and it has many elements. It was kind of interesting to see that the comprehension skills or vocabulary skills that were trained in the Let's Read and Talk intervention, like these mathematical activities group, were equally good in these kind of linguistic skills. So we didn't deprive, we didn't harm the kids. I remember Leuven in maybe 20 years ago, and maybe in the some of the first presentations of SFON, I know Leuven was there earlier, that's why I'm saying, he asked me sometime like, is this something that when children start focusing on number, that then they miss something else? And it seems to be that actually early math activities can be such that also the language skills and speaking and this can be promoted quite nicely. So the last thing, what are the implications? So there's a very exciting times now in Finland, because we are trying out now a new curriculum for 2-year preschool program. So we have had only 1-year preschool program so far, but now we are trying. There's an experimental super big setting in Finland, and the curriculum for that is just published. And guess what? It has this SFON based ideas there. So the aim there is to guide children to start focusing on mathematical aspects in surroundings, and we are with that curriculum to promote mathematical thinking in a very play-based ways and making the math visible in everyday situations. And the emphasis is really on the play and opportunities to investigate different mathematical aspects and promote skills those ways. And we have been developing online courses. So one implication is that based on these intervention activities, we have taken them into this kind of pikkumatikka course, online course, and with a take next fall, we are actually planning to translate this into English. So maybe someday you could be also kind of enjoying our activities there. And there's the kind of mathematical perception and observations and SFON-based ideas are heavily in there. So guided small group activities, and then what is a pikkumatikka expert, like notices math moments, recognizes math skills, adjusts guidance according to children's individual needs, gets excited together with the children, and then notices that math is everywhere, use opportunities for counting and mathematical thinking. So the last thing I want you to remember about how to promote early mathematical skills in daycare is that the educators need to first have math goggles on. And one way to do it is to increase and decrease numbers of items. Thanks.
Excellent. Thank you, Minna.
How much overtime?
Well, we're 7 minutes over, which is yeah. I think if you want to stick around for discussion, you know, please feel free. Obviously, some of us may need to go, but I want to thank all the presenters for their presentations today. I want to plug once again our special issue in Mathematical Thinking and Learning that has at least many related topics there. And also a nice discussion by Matthew and Glees. And yeah, so is it, yeah. Thank you all for being here.
Everyone, fantastic presentations.
Sorry, I didn't hear what you said.
Perhaps the floor is open for discussion if there's any questions for any of the presenters or.
Yeah. Hey, can I ask from the others?
Yeah, go ahead.
Okay, yeah, so Nore, I was wondering if I got it right, like the grouping that you did, the longitudinal grouping, like did you do that based on like how many times was it, like 3 measurement points, like when, and across those? So
yes.
Okay, my question is what is the nature of SFOP if you can do this, because you are grouping them based on their future behavior in a way, aren't you?